Woo! All right, well, we'll have to wake you up more. How's everybody doing? Good. Awesome. Well, welcome to PyCon 2023. It's my first chance to say that this time, so if it's your first time, welcome for your first time. If you've been here before, nice to meet you. So we're excited to talk to you today about best practices using Python for serverless applications. So if you're here, you probably have some inkling of what serverless is, so we won't touch too deeply on that, but we'll go through some good overview stuff. All right. So first off, you probably want to know who the heck we are and why you should listen to us about this. I'll let Brian start, actually.
Hey, everybody. My name is Brian McNamara. I'm a distinguished engineer at Capital One. I work in our retail bank where my attention is primarily on serverless applications. Prior to my time at Capital One, I spent several years at AWS working as a serverless specialist. Also had a chance to work at a startup that was basically using serverless services under the covers. With that.
Awesome. And I'm Dan Furman. My social media is up here. You're welcome to connect and follow both of us. We talk about this stuff relatively routinely on there. I'm also a distinguished engineer at Capital One. I work in our card line of business in the card tech space. And my job is to transform the way we do data, trying to take different approaches, find better ways to make better decisions for the end customers with real-time information. And I tend to be a serverless advocate within card. So let's go ahead and jump in and kind of talk about, well, why should we use Python for serverless apps? When we're talking about serverless applications, we mean compute instances that you don't need to manage. If you need to actually run something in a code space or in a technology space, you may be used to managing a container or provisioning a server or going in and doing that. What we're talking about is things that allow you to execute code without any of those. And they scale very nicely. There's a lot of fun stuff there. But why Python specifically? It comes down to a couple things. One is a theme that you'll see from us over and over. Simple is better than complex. It's just not fun to deal with a bunch of complicated things. Can you lock down the server? Can you build the container? Can you do all that stuff? Of course you can. You know, your Python engineers and developers, you can definitely do this. You do it on your laptop every time you run the Python REPL console. But do you really want to do that in production? If your application is wildly successful and it goes from 10 TPS to 4,000 TPS, is that something you really want to go in and re-provision and reset up for whatever's there? It's hard to manage. But serverless meshes very well with Python because it has the same kind of development cycle. So just like we're used to running a test suite every time we write a couple lines of code in the Python world, we can do the same thing inside of the serverless world. Because we can constantly deploy our application, we can constantly keep it up to date. We have the ability to run through really as quick as we want to, and we can run as many releases as we want of that code out there. It's fantastic for scaling. I mentioned kind of some of my baseline numbers there of it doesn't matter whether you're invoking a batch job once a day or if you're running something that's at 4,000 TPS, you can do that in the serverless space at a really nice low cost. And the reason for that is that you're only paying for what you consume. And this is kind of the core tenet of what I'm calling serverless services. I know there's a few operational definitions out there. But if its cost is based on usage, and then you factor in total cost of ownership, which is your time as a developer or an engineer or a data scientist to keep maintaining that code, the more we keep that time for you focused on where you're adding value, the more profitable you are for the company because you're getting more work done and you're not having to deal with that keep the lights on kind of work. So total cost of ownership is extraordinarily small. And because Python scales so well in the serverless world, it gives us a way to do extraordinarily rapid scaling and rapid upkeep. There's a few kinds of serverless applications. We'll be demoing only one of these today, but it's important to know that this pattern supports way more than what we're going to have time to talk to you about in this hour. We're going to be going through an API provider example, because while we tend to think of API clients as long-running things that are listening on port 443 and they're processing all of that information, in reality, every call that comes in, you can think of as an event. And if you start processing individual calls as individual events, you now have the ability to scale out and use load balancers in front of that. And imagine not just an army of containers, but an army of containers. You've got a huge amount of horizontal scaling that you can do because everything runs that way. We'll also touch on streaming data processors. So if you're going to process data that's coming in real time, could be video, could be audio, could be data events that are coming through, could be you taking your favorite social media and piping it through a data stream. We can process what that looks like. And then the other one that I'm excited to get a chance to kind of talk to you about is the machine learning inference. Because when we're doing machine learning, we tend to run our training system in enormous clusters that are accelerated by GPUs and have all of these requirements with them. But when you get to actually running that inference code, it kind of is a different story. When your production environment is not the traditional environment that everyone's used to. And because all of these are events that are coming in, your code is really gluing things together. So how do you make sure that the intent is satisfied for what's there without writing more code than you need to, which, again, why do we do Python in the first place? Because simple is better than complex. We don't need to put a whole bunch of additional engineering into that. One of the other things that's really nice with serverless applications is we get to logically organize our code. If, for example, posting a new payment into your account is something that's pretty highly sensitive, and that's something that you want a certain level of security on, but getting the current account balance, well, that's probably okay as long as you know who it is. We can segregate those code bases so there's no chance of something invoking a function you don't intend it to invoke, and it allows you to keep that logical organization there. So let's look at some architecture, because it wouldn't be that, or it wouldn't be a presentation if we didn't at least draw some pictures for you. But in an API application, we'll use AWS as the cloud provider platform as an example here. You can use the Amazon API gateway to directly invoke your Lambda functions. And Lambda is the function as a service offering from AWS. That function can then connect to databases, it can handle queues, you can work on pub/sub data, you can even send those to an event bus and have other events work with it. Stateless functions work the best in this use case, and you want to interact with other services where needed. This could be a cloud-managed service, or this could be something that you're hosting yourself. If you have background with AWS, you may recognize some of these symbols as pertaining to specific services, but it doesn't matter if you're running RabbitMQ yourself, or you're using Amazon SQS, or you're using any other version of a queue. It all works. The same way with pub/sub and everything else. You know how to connect to it. You've already got the libraries for it. That's one of the cool things about the Python community is I can go to pypi.org and pull pretty much whatever I need to. And we can come through with that, which is really nice. A streaming data application looks a little bit different. We start with something like Amazon Kinesis or Kafka or whatever your favorite streaming provider is on the front end. We can invoke and then work on those elements that are coming in. We could do that in Lambda. We could do it in AWS Glue. And the difference there is, what are you doing? If you're working in the Lambda environment, it's very short-lived events, not doing aggregation, pulling individual data elements together, transforming or enriching in some way, and then exhausting out to either another stream, a data lake, a database, whatever it needs to be. In the world of AWS Glue, you're talking about something that's either a Ray or a PySpark job, where you may be aggregating data across the stream, you may be running higher level analytics and metrics on that, and as you process that data through, you want to make sure that you have a managed PySpark instance. And yes, I said managed PySpark instance. Isn't that cool? Like, I got very excited when I saw this the first time of, you mean I don't have to configure it? No. It'll run pretty much whatever I want it to, which, again, very nice. The last thing, or the last architecture picture we'll look at today is in the machine learning inference space. So your training data is there, you've done all of the work, you've followed all of your procedures to go ahead and update that. So when your training update happens, what you're doing is really deploying that code artifact to something that's readable by all of the different entities involved. So whether you send that out and then have it deploy across a fleet of instances or a bunch of containers or function as a service Lambda code, all of that data is reading from a common file mount. And you can do that in AWS using the EFS system. So that training update goes out that way. Your code update, on the other hand, gets deployed directly into Lambda, and then your change orders kind of follow what the DevOps path for all of us who are more of an application or a web background are. So it kind of brings things together. We don't have to worry about what that looks like, which is really nice. The really cool thing that if you're in anything that has model compliance associated with it, which I think everybody does if you're doing data models, you have versioned asset numbers for what that training data is that you're pushing into here because there's no way for it not to be versioned. It's kind of a cool way to invert that a little bit, and it forces something that I think is a cool practice. So let's talk a little bit about the serverless mindset. Hopefully you're a little bit intrigued by the concept of serverless, or you probably would have spent time doing some of the other cool events that are going on in this time slot. We're glad you're here. But as you're looking at this, there are trade-offs. When everything is an event, so is your logging, so is your observability, so are your deployments. And all of these events that are coming through have to be processed and handled correctly by using things that are totally ephemeral, where the code exists while it needs to run and then goes away. And this can happen in milliseconds, in fact, single-digit milliseconds to come in. You're not going to have the classic constructs where you're going to SSH into an instance and go Splunk through the logs using sed or ACK or writing a script to be able to do that. You need to be able to exhaust that correctly. So having ephemeral code is one of those things that requires a little bit of a shift from what you may be used to. The code's also isolated. I touched on this with the idea of, hey, I may want to do this strategically for security reasons because my Git has a different footprint than my post does, but I could also isolate different elements of my code in different ways. For example, if I'm streaming data in a real-time interface, I may serve that customer traffic immediately and then fire off another event that then streams it into my data lake. My customers' experiences improve because they got their answer faster, and I have guaranteed delivery on that data into my data lake, which means I don't lose anything if an instance goes down, I don't have to recover it, or potentially have to mount volumes or anything along those kinds of lines. Code's self-contained. This is one of the things that's really nice because you get automatic versioning of this. As you go through the code and as you start doing deployments, all of the code is wrapped into individual segments and elements so that you don't have anything that's bleeding through. And last, it scales without intervention. Because you're paying for what you use and because those call volumes are what are determining what's there, you have the ability to allow the service to auto-scale out, and you don't really have to think about it. If you start running into things where you're finding a limit or you're finding something else, it's observable. It's something that you can alarm on. It's something that you can proactively work through. And the really neat thing, if you're into anything on cost controls or anything like that, your QA environment, which tends to provide a little bit less traffic unless you're under perf testing, which is for a short duration of time, 3 hours a day, something like that, has very, very low costs because you're not processing traffic through it. It's a really nice way to kind of drive that back to really a shift left in how do you think about where does that come from. So again, I mentioned trade-offs. What should we consider here? How do you observe your application? How do you get those logs, metrics, and performance numbers that really drive what you should be doing? How do you test, build, and deploy that application? How do you architect it? Is Lambda the right service to use here, or is any function as a service the right thing to use here? As you look at these kinds of questions, one of the things that I'll say keep in mind is this is not a silver bullet. It's not a magic solution. It works in more cases than it doesn't, but there are exceptions you need to be aware of. If you need specialized hardware, like a graphics card to accelerate the performance of what you're doing, you probably don't want to be doing that in an ephemeral instance that's going to die and go away every few seconds as soon as it processes an event. You want to, or if you're going in and you're doing kernel tweaks and kernel optimization, if you're doing something like that, this is probably not what you need. If you have long-running workers and processes that you can't decouple and put into something that's working behind other events or firing those events, that's not something that's going to work well in a serverless context because it's got to be running all the time. The other, another consideration is if you have large payloads, 5+ megabytes of data, there are things that you can do to make that effective and efficient, but you probably are in a case where you're processing an enormous amount of data, and it may not be the right thing for it. At its heart and soul, try and cut with the grain, not against it. It's certainly a paradigm shift to think about things as events, especially API calls, when we tend to think of those in terms of, well, how many can one thing handle before it falls over, as opposed to, how many calls did I get? I don't care if that's running on 1 or 100,000 instances, it runs. We're good. So understand it's a little bit uncomfortable when you first get started with it, and there are places where there's an edge. But to go back to a point I mentioned a second ago, this works more often than not, and more often than we find people think it does.
One thing I would add too, if you have any questions afterwards, Dan and I are going to be at the Cap One booth, so hit us up. We're more than happy to chat.
Absolutely. And if you want to talk use cases,
Yeah.
we'll find a whiteboard. So let's go through and try and give you some insights into how Brian and I tend to think about this at very minimum. So how do you know what this application's doing? Well, the rules of observability change, and I kind of alluded to this because when everything's an event and everything's ephemeral, it's no longer something you're going to SSH into. It's not something that's going to be outputting physical files that you're going to file beat and aggregate into some downstream aggregator. It's something that's happening in real time because logs are events too. Same thing for telemetry. Anything that comes in on the tracing side, that's individual events that you want to stitch together for what's there. Same thing's true of metrics. When we output things that tell us about the health of our functional requirements or our non-functional requirements, those are things you want to track, and you want to make them available for you. Enough with the questions. Here's the advice. Structure your logs. This is a big one. JSON is really nice for this, and the reason for that is across everything that we've looked at in function as a service, JSON can be natively interpreted, which means you can dive through it, you can get very fast search speeds, you can work through all of that, and it's a really nice way to make that work, and you can always send it downstream to an aggregator, whether you're using an Elk stack, a product like Splunk, something else, you can always send JSON data forward, which is really nice, as opposed to unstructured data, which then somebody's got to parse and you got to put compute power behind. Set a retention period for your logs. This is one of those things that we tend not to think about too much in the world of long-running hard drives. But you probably don't need data that's 7 years old. Or if you do, you probably have a really defined reason for it, and you don't want to keep it on some instance that may die at any point in time or is running as a spinning hard drive. You probably want that in something that's got a lot of redundancy built in. You want to log what's necessary for debugging. You want to be able to analyze what your application's doing, where it is, how it's running, but you don't want to log more information than really is needed. Now, why? Well, because it makes the logs a little harder to search. Imagine a stack trace of thousands of lines of data tracing across a bunch of things into packages and out of packages. Maybe useful at one level of code, probably less useful at others.
And one other point I would add there too, that's going to have a direct effect on your cost as well. So when you're using a cloud provider like AWS, they'll happily accept whatever you choose to log, but they're going to ask you to pay for it too. I've seen customers in a previous life where their Lambda cost would be a couple hundred dollars a month. Their log cost would be a couple $1,000s a month. So again, be aware.
Yeah.
It's an awkward conversation to have after the fact.
Absolutely. Yeah. So you want to make sure that we're trimming that down and not keeping more than what we need. And the log retention period helps with this, by the way. You don't have to keep it in one service. There may be a threshold that, say, after 60 days when your customer discussion period and research period is over, you want to keep those for another 6 months so you can see what normal looks like and get a data-backed picture of what normal is for your app. That's great. It doesn't need to be in the log management service. Drop that into a data lake, put it somewhere where you can query across it, and you have the ability to actually keep moving at that point. Custom metrics are absolutely vital to most of these applications. Now, we're used to this in non-serverless context being something that's done by a third-party aggregator or something downstream that's reading logs and trying to extract intelligent information out of it. We can shift that not only left, we can toss it right next to the point where the application is running. And when you're emitting things like the embedded metrics format as a standard, this is asynchronous. It doesn't impact your customer experience. It is guaranteed to be captured and caught. You can work with that data, and that's how you can build really business-centric dashboards in code, which is really cool, because now you don't have to worry about what are the metrics and what are the namespaces that we need, how do we compose that together. That dashboarding becomes much simpler. Now, that said, there are different types of metrics and statistics that should be used here. If you're looking at the average amount of every transaction coming in, for example, to find out how did the day go. Say you're running a fantastic coffee shop and you want to know what your average ticket price is. Well, that would make a lot of sense for an average. If I was looking at the average response time for my application, though, well, I don't want an average of averages. I want to know what the customer impact was. That means I need long tails. Which brings us to metric math. You can do all kinds of different functions on this. You can pull the statistical anomalies and you can pull the correct data, and you can do this by actually running that information through EMF and then letting it be aggregated immediately as soon as it's exhausted. Touched on this briefly, but I'm going to emphasize it because I think it's important. Don't look at your averages. It's a good tool to know where you are, but look at P90, look at P99. When it comes to response time, when it comes to error rates, when it comes to high-end latencies, this is what impacts your customer, and this is where their experience comes from. If you have something that's responding in 100 milliseconds at the average, but the P99 is 4.5 seconds, that's a really inconsistent customer experience. Sometimes your app is faster than humans can perceive. That threshold's around 250 milliseconds for what I'm using, and if anyone has better information, especially data science and bio people in the room, please tell me later. But we move off of that and we go to the 14-second line. Well, that's a long page for an API call, or that's a long thing for an API call to come back and update information on a page. We can do better. Last tip, use AWS Lambda Power Tools. This is a fantastic open source project. It's published on PyPI, and it's really a stand on the shoulders of giants moment. The best practices that we're talking about here have been codified within this Python package, and they're really easy to implement. Don't take my word for it. Let's look at it. Inside of logging and trying to get some metrics and some logging into here, this is actual code. Admittedly, it's a little bit of a simple example because it would fit very nicely on this slide, but we're doing just a couple things here. We're importing a logger and a metrics utility. We're grabbing some standard types of metric units. We're doing some typing to better involve your developer experience and make sure that we're getting good auto-completion from whatever your IDE of choice happens to be. And then we're just doing a couple annotations. We're going to inject the context so we know if this is something that is a brand new scale-out event. You may have heard of this as a cold start. Or if it's something that is working from an existing container that's done processing an event right now. We can also go through and we can add custom data to this. You can see that we're collecting payment info right under the handler method and just kind of telling us what's going on. Or you can do something far more advanced where we're actually giving a dictionary of data here that's going to be interpreted and exhausted to logs. We can even add success charge metrics here. These are arbitrary things. We define them as we go, and it's entirely defined in code. Those are picked up and become things that we can search on, which we'll go through a little bit more. Tracing and tracking work the same way. PowerTools seamlessly does this. You annotate your functions, you instrument your packages, you inject your keys, and those can be any arbitrary key you like. If you have some kind of ID to identify transactions across a distributed system, that would be a great thing to use as that metric itself. Kind of abstract in bullet points, but let's look at the code. Again, this is pretty sparse amount of code, fair amount of comments in there for being as big as it is. But to implement the tracer, we just go ahead and implement it. And then by using the annotation tracer capture method, we're going to know exactly how long these things take. How long is it taking you to generate a UUID for? Is that really the thing you want to do for that? Kind of a silly example. I know it's part of standard library. I know it's pretty fast for that kind of stuff. But if you're trying to benchmark two different things, This is a way to grab data around it, which is really cool. Capturing methods that are much more complicated, like actually processing a payment, it's a nice thing to just add that in as a subsegment. And by 18 character strokes, it's in there. It's ready to go. So we've talked a little bit about what this is, but we're at PyCon. You're not here to look at slides. You're here to look at code. So I'm going to walk away, and Brian is going to start walking through some of the code examples within this. There you go.
Cool. Thank you very much, Dan. So have a sample project in my account. It's called PyCon 2023, because I'm creative. The project itself is built, thanks, Dan, using Cookie Cutter. If you haven't worked with Cookie Cutter before, it's really, really good at templating things. The other nice thing is that the project uses the AWS SAM CLI. So I'm being really opinionated here. The examples that I have here use SAM, which is a open source project from AWS. It stands for the Serverless Application Model. You can think of it like CloudFormation for serverless specific things, but there's also a corresponding CLI that lets you work with serverless applications locally, or you can use it to deploy to AWS as well.
I'll add in that if you're looking at this from the perspective of, I don't use CloudFormation, we use Terraform, we use Ansible, we use something else in our business right now, SAM's not going to force you to use the CloudFormation template. One of the things that Brian's going to talk through here is that SAM can actually be used for local testing environments. So just like you stand up a local environment for Flask or Fast API, you have the ability to do that with SAM and process those events in real time. We'll go through that.
So because I'm big on architectural diagrams, we have another one in here. So this represents an API, and our API is comprised of two Lambda functions. One that handles payment requests via the post HTTP method, and one that lets you get your balance using a get. If you're following along at home, there is a make file within the repository that we can use to make some of this work a little bit easier. So make install will basically install the necessary Python package dependencies locally for the project, and it'll also go through a separate target where, it'll install pipenv as well as the requisite modules. I'm using pipenv here. Not super opinionated. You can use whatever Python package manager you like. The one constraint for those of you who are using AWS with Python Lambda functions, your dependencies have to be in a requirements.txt file. So again, just keep that in mind. Pipenv has a really easy way to convert your pipenv file into a requirements file, but it's not a hard, that in and of itself is not a hard rule.
I'll add in, if you find yourself using a different environment manager, go for it. We literally added this on top of SAM. This is not a SAM-directed thing. And all of these practices that are kind of made and codified by the AWS Lambda Power Tools stand on the shoulders of the Python community. When we talk about data validation, we have Pydantic at our fingertips. We have fast JSON schema at our fingertips. When we're talking about logging, this is a best practices implementation of standard library logging. None of this is magic. This is cookie cutter. This is a way to bring that stuff forward. The goal here is to not be opinionated about what's there. It's to make sure we're providing the best way possible to do that. And by centralizing that into one API and one package, we get the ability to do that as broad level developer adoption, which frankly makes people happy. And that's one of the reasons I keep coding Python. It makes me happy.
So in this case here, we are using SAM. SAM, if you're not familiar with it, quick show of hands. How many folks in the room have heard of SAM, the Serverless Application Model? Okay. For those of you who haven't heard of it, basically it's infrastructure as code using cloud using AWS CloudFormation under the covers. So think of either YAML or JSON files being used to represent AWS resources. That's all. It has a reputation for being verbose, and I'm not going to fight it. SAM actually makes it much easier to do serverless specific things. So one of the things that you can do with the SAM CLI is make sure that you're working with a valid template. The point of the validation here is to shift left. So you don't have to wait for a build to fail. Like if you're using, like a shared resource to deploy your cloud assets, like it may take time. Well, you don't have to spend that time determining whether or not your template's valid or not. Use the tools that you have at your disposal. It actually does use CFN lint as well under the covers, so you have a sense of whether the template itself is valid and whether it's actually adhering to best practices. Like any good baking show, I have instructions for what to do. So I have a make target for all that will actually that'll actually build your serverless application and get it ready for deployment. Now, we're not going to actually deploy yet because,
Conference Wi-Fi.
Well, and we're also on the README where we're interacting with our API locally. So there are a few different ways that you can approach testing your API locally or working with your API locally. One is to actually pass in an event. So, as Dan mentioned, everything in Lambda is an event. Events can come from a number of different sources, whether it's Amazon's API Gateway, S3, SQS, SNS, name it. In this case, we have the option to pass in a valid event that's actually generated by an API Gateway endpoint into our Lambda function. Now, when you're doing this sort of work, this early experimentation, it's really, really good to test the happy path, things that you expect to work well and iterate as you learn, but also test for failure as well. So, again, I do have a couple of make targets as well for sending a valid balancer request as well as an invalid balancer request, valid payment options as well as invalid payment options for any number of reasons. So I'll show you what that looks like. Again, we do have make targets to make this look a little bit easier. So
Oh, yeah.
thanks. Gotcha.
And then just communicate that.
So is that clear for everybody? Clear enough? So in this case here, I've already built my Lambda function locally, and I'm passing the event through. Now this is actually representing what the Lambda function is actually doing. So I can see that a request is actually coming in. I can see the event, like in the Lambda function itself, I'm emitting the event, but I'm actually doing something with the event itself. So,
by the way, events are dictionaries, so while there are different forms for each one of the cool things about Power Tools is it includes type hinting for each of those different event types, and it includes the ability for us to generate those events from the local CLI. So you don't have to guess at what these things are.
Yeah.
They're auto-generated for you, which is really nice.
and the SAM CLI has that capability for any number of different services that can act as events for Lambda. So in case you're wondering what an event might look like, as Dan mentioned, it's essentially a JSON payload. This is representative of a real API gateway request to a Lambda function. So you can, because it's JSON, it can be parsed and interpreted. So let's take a peek now. We know that we can test local, valid local interactions. Let's actually take a look at sending an invalid payment request. So in this example, a valid payment is one that has a user ID associated with it, a payment date that is later than or equal to today, where the dollar value is between $1,000 and $10,000. Anything,
Maybe a little bit simplified.
yeah. This is not really how Capital One does things. So let's take a peek at what that same interaction looks like when we send, let's say, an invalid payment amount. So again, we have a make target.
And if you go in and download this repo, it has the instructions for how to actually instantiate the whole project yourself. It'll scaffold it just like Brian has here. So you'll have these make commands, and you can look at what it is behind it. We could walk you through SAM in depth, and we could probably talk about it for, 2-3 hours and not
more than
notice.
that.
But that would be really boring. So we built you a make file.
So long story short, we're able to do input validation here. You may not be able to see that so clearly, but we can see that the request ID, or that the request failed because the amount that I passed in, wasn't between 1 and 10,000.
And this is a good example of what we're talking about when we reference, what do you need to debug the application? Do I need to know which specific validation failed? Do I need to know what field failed? I need enough to identify the application. I don't necessarily need to know every call made by this application.
Yep. So I mentioned we can pass these events into our Lambda function directly. If we want to, though, we can actually start a local, a Docker container that represents an Amazon API gateway. So in this way, rather than interacting at the command line and directly passing in an event, you can use any HTTP client at your disposal. So what this means is if you like Postman, if you like curl, if you like anybody else using anything else like requests, you can do it.
Anyone heard of requests? Yeah. So if your acceptance testing, for example, is running just with requests because you're making API calls today, you do the exact same thing. And instead of having it be something that's locked in a cloud provider or locked in a service provider for functions as a service, you can run it right from your desktop. So it's a full shift left. We have yet to touch anything that's related to the cloud deployment.
Yep.
We still have confidence that it works.
So this is a sample request being made to my local Docker container for a valid payment. So I'm passing in a username, and I can see the output of that whole thing. This is what my Lambda is emitting. Similarly, I could go through and do the same for an invalid payment. So I know I showed you an invalid date before, or invalid payment amount. Let's take a look at invalid date.
Your local.
Thank you, Dan. Invalid date. And we can see ultimately the same outcome. The request is going to fail. The HTTP client is going to get a 400 because, now this isn't being returned to the client. The client's only saying it's an invalid payment. But because we're good serverless developers, we can actually go back after the fact and determine why it failed. In this case, it's an invalid date.
And again, what makes it invalid here, and you'll see this in the code, and you're welcome to dig through it in as much depth as you like. You're welcome to question us at the end and interrogate us.
Just don't judge the code too harshly.
Fair point. We're standing on the shoulders of Pydantic here. Whether you love or hate it, it's a really powerful tool within the community, and we happen to really like it. So it's a nice way to bring that in. Again, this is not about picking tools that are out of nowhere or that you've never heard of. This is running Pydantic under the scenes, and you can do the exact same thing with FastJSON API, or FastJSON schema rather, in order to make sure that that's working, which is again kind of nice.
Now, in the testing portion, we're actually making use of PyTest. Again, that's an opinion in this repository. You can use I'm not telling you how you should test your Python code. What I am saying is that you do have the ability to test your serverless application because it's a Python application. That's it. Yeah. It's running in in a virtual execution environment, but it's still Python code at the end of the day. So we can do things like make test, right? Now this make target is literally running a PyTest command where my tests are really nothing more than standard Python code. So here's what I'm doing. Like I'm importing my Lambda function. I'm passing in an event and context, and I'm checking if the expected amount matches what I actually got. Standard testing procedures. I'm not doing anything special just because it's a Lambda function.
In fact, in testing, you don't even need to know that it's a Lambda function. You pass in an HTTP request, you get back an HTTP response, assert that that worked, you've got your outside-in tests now covered. As you find you're developing the application more and more, cascade into more detailed tests, whatever framework you happen to use on that.
So up to this point, we've essentially written our code, we've interacted with our code, we've tested our code locally. We haven't done anything in AWS yet. I'll highlight how to do that using SAM, but ultimately, I'm kind of going to, I'll gloss over this a little bit. SAM does have the ability to both build and deploy your serverless application. There's a mechanism that you can use to actually store values that make subsequent deployments easier, where you don't have to be prompted for information. And there's sample output here for what a guided deployment might look like.
Again, we gave you the makefile command mostly because we're not teaching SAM CLI on this.
Yeah. But let's assume we ran it, because I did last night and it actually worked. We actually have a live API based on our underlying code here. So at this point, we have a URL that we can use to both get credit card balances as well as post payments. Once it's deployed, we can actually use our HTTP clients of choice, just like we were when we were working locally against our Docker container. So in this case here, you can post payments using curl, Postman, whatever. I'm not opinionated, but the point is, up to this point, it's really easy to go from ideation in using Python code to actual deployment. Like, this is real. Remember the first time I saw this actually happen, it was pretty cool.
And it's worth noting, too, that this is not AWS specific. If you're using something else to deploy, whether any kind of CI/CD, these are local commands that are great for hacking around in Brian's personal account, my personal account. When you're doing this at enterprise scale, you probably have something that's CI/CD in the middle. It may be a cloud-specific system like Code Deploy. It may be Jenkins. It may be GitHub Actions.
Yeah.
All of these things work. It's just a matter of plugging in, hey, run this for me, and you're ready to go.
Yeah, and some actually have really, really good integration with SAM as well, specifically. So regardless of whether you are using other tooling, like if you happen to be using SAM, just know for a fact that there's really good support with various CI/CD tools. So let's get to the fun stuff. Now our application has been deployed. Let's talk about observability in your app. So, as Dan mentioned, things change a little bit with serverless applications. In many ways, we have to be more disciplined. You can't rely on SSHing into a host or running a Docker command to execute a bash shell. This is a short-lived function that won't be around. So you have to be mindful in how you emit your observability data, logs, traces, and metrics.
By the way, your cyber people will thank you for this because there's nothing to log into. Yeah. Therefore, it's much harder to get in and do something bad in it.
Yeah. So in our case here, we're actually using two different services that AWS offers. Again, I'm using AWS here because I'm deploying to AWS. Not super opinionated. If you're a fan of Prometheus or if you're a fan of Grafana, you can take advantage of these open tools. In this application, we're emitting data to X-Ray to capture tracing data. We're also using CloudWatch as a service, so we're using both CloudWatch logs and CloudWatch metrics.
By the way, even if you're using CloudWatch logs and metrics, and for some reason you don't like the console, you have additional security around console access, pipe it to Grafana, pipe it to Prometheus, pipe it into Splunk, run it in Elk. Whatever you want to do, you can move that data forward. Yeah. What it does is it drives it left. You've got the sensor milliseconds in the application, which is really nice.
Yep. So earlier Dan called out there were a couple different places where we added a few decorators to our code in the hopes of essentially providing more valuable information. Let's take a look at some examples of where we do that in code. So this is our handler for post-payment. We can see that we're importing the logger. We're also importing Lambda context. Now, what this means is that we can wrap our handler and say, hey, for every downstream call from the handler on, wrap contextual data. Now, what does contextual data mean? Well, things like the ARN, okay, the unique identifier for the function, including either the alias or the version. Things like the amount of memory allocated to the function, whether it was a cold start or not. Like all this information can be emitted in your logs just based on context, which is really cool.
And just to drive a little bit more there, because that's an easy thing to say, the implications kind of like would require us to drop the mic and the sound people yell at us if we did it. Because the answer is, as you're doing this, all of that information what version of it was deployed, what version of it executed it. If you're in the middle of a canary deployment, was it the new thing that failed or was it something in the old thing that failed? You don't want to prematurely trigger a rollback, especially if it's just a bad request coming in every once in a while from somebody. Those things are automatically instrumented for you here with those 3 lines of code.
Yep.
That's it.
And what's really, really cool too, the actual act of logging is pretty straightforward. Literally it's just a call to the logger. That's it.
And give it a dictionary.
Yeah,
you can serialize it as JSON.
Yeah, like here, like we're just passing in value that came in from the event. So if I want to know, user ID, amount, outcome of the payment date, timestamp, like I can have that automatically structured in my log. Now, many log aggregators or log service providers will consume JSON really, really well. You don't have to write the regex from hell in order to make sense of that log, which is awesome. I've written enough of those, it's not fun. If you haven't, you're lucky. The important point to note about logging is you can capture all the relevant information and have it discoverable. So when bad things happen at 2 in the morning, your mean time to resolution hopefully becomes a lot shorter because you're not hunting through a lot of log information. It's all structured there for you. The other point too is that the amount of code that you need to write to add this instrumentation is minimal. Like as a developer, you don't want to spend time, figuring out how am I going to, emit this information to my, logging service, to my metric service, to my tracing service. You want that overhead to be minimal. The nice thing is using AWS Lambda Power Tools, it's really easy. There is support, we're obviously at PyCon, but don't think it's just limited to Python. There's a Java version and a Node TypeScript version as well.
That's really profound, and I found that to be really cool because while this package codifies best practices and gives you an easy way to download, import them, and get working on them, this means if you're a polyglot programmer and you spend part of your time in Java, you spend part of your time in front-end work doing Node, maybe you're writing back-end code using Node, it's the same patterns, but they're idiomatic to each language. So you're not going to be dealing with weird things that don't feel like they fit here. You're going to be having a very similar pattern as you keep working forward.
Yep.
And I'll add one thing to the tracing point because I forgot to mention it earlier. Instrumenting individual function calls is great if you have a complex function there. Let's say I'm making a database connection through PsychoPG, or if I said that wrong, I apologize. I've only ever seen it written, not heard. Yeah, I do follow them on Twitter, but they don't include pronunciation guides. Or if you're running requests or AIO HTTP, it's as simple as just saying when you declare your tracer, instrument these packages too. Anything they happen to do in the code, please track that as well. So you're not having to put that implementation on every function, especially if all it's doing is doing retries and making sure you get a good response out of it.
Yep. Now, this is just a really, really quick example showing that all of these new fields that we're adding to our log can be automatically discovered. Now here, again, this is an image representing AWS CloudWatch Logs Insights. Essentially, it's a way to query across different log groups and actually do some really cool things. But the important point is that those fields that we didn't add are automatically discovered. Things that we did add are automatically discovered as well. So the discovered fields list is actually quite long. We can use all of those fields when doing comparisons, looking for values in specific fields. It's easy.
So if you have a one customer example of something that's gone wrong and people can't figure out what it is, you can search that customer's transaction directly, and you can see all of the different things that hit it, not only in your function, but across the service mesh, which is really a cool way to approach debugging and troubleshooting.
Yeah, so like using this example here, how many of you support APIs? Quick show of hands. Okay. How many of you have had to troubleshoot? Okay, like I had a request come in. I know this is the request ID. What the heck happened afterwards? What happens once it left the API? It's hard. It's hard unless you have a correlation ID, some way to associate that initial request with what happens downstream. Now that can be done via trace, but it can even be done in logs. So different services may have the ability to create a correlation ID and allow you to use it. So in this example here, I'm basically looking across multiple log groups. So my API, I'm making sure I'm logging my API requests. My API, and I want to see what happens to a particular downstream request in my Lambda function. I can do that pretty easily. Now I have a request ID in my API gateway that corresponds to a correlation ID. I can search for that same value in multiple log groups and see what happened. So like in this example, I have my API gateway request. This is the log.
And this is what we mean by the way of JSON being really nice. I'm just going to jump in and show this, because not only do we have this native data from the ingestion timestamp at epoch, we've got the message itself in JSON format, we've got the HTTP method, what came in the IP. All of these are searchable, as is this message field. This is just a nice way to display it for this query.
Yep. So I have this information from my API gateway log. I also have this information in my Lambda logs as well. So I can find out what happened. I can see the amount, outcome, payment date, timestamp. I can correlate that initial API request to what happened downstream. Really, really powerful. Makes your troubleshooting a lot easier. Now that can be done in code by setting a correlation ID. So in this case here, I'm using a correlation path defined in Lambda Power Tools. Really, really cool. I don't have to understand all the different places that request ID can come from. Because again, in the AWS world, it could be an application load balancer. It could be an HTTP API gateway. It could be a REST API gateway. It could be a native Lambda function API.
Could be a cron job.
Yeah. Well, but in this case, like the requests themselves, this is just on the HTTP side. Now there are ways that you can look at correlation paths across all these different services, but you don't have to think about it. It's already been done for you, which is really nice. I know we're running out of time, so I want to be mindful of that. Let's talk about traces as well. Dan mentioned we have the ability, or actually, let's jump into metrics. This will be really, really quick. With metrics, you should be using the embedded metrics format. Good news is there's support for it in Python, Node, and Java through the Power Tools or utility. This lets you emit metrics, custom metrics, business level metrics asynchronously. There's no additional cost to you. It's just the actual cost of the log event being stored. That's it. You don't put your users in the critical path of emitting custom metrics. Quick show of hands. Anybody ever try to emit a custom metric and have things hang for a little while because your metrics provider couldn't handle the request?
Or had a daemon start bogging down and then crash your system because it ran into memory overflow? This can't happen here. You're inoculated against it because the best practices implementation, it's already here.
And it's asynchronous, which is really, really nice. This is what EMF output looks like. You don't have to worry about writing this. All you have to know is essentially the namespace that you want to use, the name of the metric, the unit of the metric, and the value of the metric. What this gives you is the ability to have this show up in CloudWatch. So CloudWatch metrics. I can see the number of successful payments that have been made over a 1 hour window in a 5-minute bucket.
And if you have an ops center watching this, it doesn't need to be them logging into your specific AWS or account to see it. You can pipe it into any of the tools we mentioned before, from Grafana to Elk to other things that are looking at this. They have a centralized view of both, or of any region you choose to use. So if you distribute this closest to your clients and go across all 20 plus regions worldwide, then you have the ability to bring all of those together. If something's happening in one region, you can auto recover and fail over, and essentially your ops people stay asleep. The cloud itself is capable of helping you recover using these best practices, not waking you and having you go take manual resolution actions. I like sleep. It's a good metric for me of how good is this code base.
Now, one of the other things that you can do with some of the time that we have left, you do have the ability to capture traces as well. So again, ideally, you're minimizing the amount of code that you have to write to observe your application. By taking advantage of power tools and using function decorators, you can basically get tracing for free. So in other words, you don't have to instrument your code if you're using something like X-Ray or even OTel. There will be a degree of tracing built in. Obviously, you can make those traces more meaningful if you want by adding things like annotations and metadata. In the case of annotations, annotations are indexable by the X-Ray service, meaning you have a list of traces, you want to find out what a particular, show me a list of traces for a particular user ID. You can do that. Metadata you can add, metadata is not indexed. So what might this look like in your X-Ray dashboard? Well, in this case, with X-Ray, you actually get a service map, so you can understand at a high level the amount of services that are being used in a given period of time. Now, if you want to dive down into traces, you can see all the different traces that have been recorded for a given period of time.
And for anyone who's really data focused in the room, you can see what's that abnormal transaction that threw my 4 nines value. If that's what you're measuring at and that's what your application looks for, you can find that one transaction and look line by line where you implemented telemetry to find where your opportunity for improvement is.
So in this case here, I have a sense of what's happening for this one trace. API Gateway is one of the services that can add a trace ID header, so all downstream AWS services can potentially take advantage of it. I can see end-to-end how long that interaction took, but what's cool is each downstream service in turn can add its own values as well. So in the case of Lambda, Lambda is actually, or Lambda can be an active source of tracing or a passive source. It can create its own trace ID if one is not present, or it can consume one and add to it if it's already present. I can see the invocation time in Lambda itself. So I can see the overhead of API Gateway. I can see the overhead at each point of the function execution as well. Now in this case, really simple API. If you're looking at the code, you're probably laughing a little bit. I'm basically generating mock responses. I'm not interacting with anything downstream. But if you were interacting with, let's say, DynamoDB or a Postgres database or a Mongo database, or
a third-party vendor running a mainframe.
Yeah,
or you can see how long each of those things take.
Yeah, like if you're using requests or any number of other modules, you can actually see what's happening downstream. Really, really powerful stuff.
Now, if this graph looks a little off, I'm just going to draw your attention to one thing here as we go through. These are actually running in Brian's personal account right now. And while these lines look like they've got some big gaps in them, remember, our baseline for the length of this transaction is 17 milliseconds. There aren't a lot of things that respond in 17 milliseconds today. And when you put containers in front of them and you deal with auto-scaling and things like that, maybe you beat this metric. Maybe you don't. But again, this is a Python application. For a reputation, right or wrong earned in the past of being slow to execute, 17 milliseconds is pretty respectable for anything I write, certainly.
So I'll tell you what, we have covered a lot of ground here, so congrats for hanging in.
We applaud
Yeah.
you guys. Thank you.
So I'll say there are a couple takeaways I want you to leave with. One, when you're developing serverless applications, shift left as much as possible. Try to get your local developers to have a good experience locally before you even worrying about deployment. You want to make sure you test your serverless applications. Those rules don't change. Just because ultimately it may be running in Lambda, it doesn't get you off the hook. Still test your code. Use infrastructure as code. AWS makes it really easy to get started in the console. Don't fall for it. In this repo, we're using SAM. Not super opinionated. There's great support for Lambda in Terraform, CDK, or the serverless framework. Use what works. Make sure your artifacts can be deployed consistently. Another thing is use automated mechanisms to deploy your serverless app. So, as Dan mentioned here, like in this example, we're just doing a deploy from a laptop. In the real world, you don't do that, right? You use services like Code Deploy or Jenkins or GitHub Actions. Also, ensure you have good visibility into your serverless applications. The tools are there. Take advantage of them. Don't let observability be a blind spot for you. There's no reason you shouldn't understand what's happening in your serverless app.
And it's probably fair to add that we've seen lots of different observability. We talk about this a lot within our company at Capital One. We talk about it in the cloud in general. There are dozens of blog articles on it and probably more upcoming. Observability is a big thing. By having a library that codifies this and either as reference material or something you actually choose to use, this can help inform how the rest of your systems work as well. Because when we understand the best practices, when it's one event executing in a couple hundred milliseconds or in a couple dozen milliseconds, that scales pretty well when you start talking about something that, okay, well, this is going to run longer and it's going to be able to go through. Can you get that same level of observability and visibility? How hard is it? Bringing some of these things in, because we're already talking about standard Python conventions and standard Python tools, use it as a reference implementation. Bring that in, set your own standards for your organization, and drive what makes sense for you.
Big thanks to everybody for hanging in.
Yeah, really appreciate you coming.